Welcome to the part 2 of our series on career path for chemical engineers. In this video, we will explore the diverse and exciting roles that chemical engineers can pursue in various industries. And as we all know, chemical engineers have an option to explore a wide array of opportunities, so do watch the video till the very end and do not forget to like, share, and subscribe to Chemical Engineering Life channel for more videos. Let's begin. The career path that we have in the beginning is process design engineer. A process design engineer is the person that develops and designs chemical processes and systems for manufacturing, ensuring efficiency, safety, and scalability. Think of a process design engineer as the architect of industrial chemical processes. Their job is to design how a product is actually made on a large scale, starting from a very small lab concept and turning into a full-scale, continuous industrial process that can run 24/7. Obviously, this goes without saying that this requires a great deal of engineering judgment and deep technical planning, considering both the chemistry involved and the mechanical systems required to carry it out reliably at scale. And they are involved from selecting the right type of equipment to developing detailed flow diagrams. And process design engineers find themselves planning out every single step of the production process. They are responsible for conducting feasibility studies, modeling chemical reactions, modeling separations, and working closely with simulation tools to predict how different components will perform under real-world conditions. Their focus is on making sure that the process is not only technically feasible, but also safe, efficient, scalable, and most importantly, cost-effective, striking a careful balance between performance, cost, and safety. Think of a process design engineer working within a biodiesel production. A process design engineer working on this project would be responsible for the overall designing of the entire process flow from start to finish. And that obviously would include pre-treating the raw oils to remove impurities, designing the trans-esterification reactors, specifying the equipment needed for separation and purification, figuring out ways how we can store the final biodiesel product before shipping it out to the clients, working closely with simulation tools such as ChemCAD or Aspen or even MATLAB, creating and approving process and instrumentation diagrams, and most importantly, sizing of the equipment, performing economic analysis, and calculating the heat and mass balances. But most importantly, they will be the ones figuring out the piping and instrumentation diagrams so that the factory gets built as needed. And these decisions are very critical because they obviously define how well the plant will run, not just on day one, but for many years into the future. Now the best thing is that process design engineers are employed across a wide range of industries, such as oil and gas industry, pharmaceutical industry, food and beverage industry, energy industry, literally any industry that relies on industrial mass scale production will rely heavily on process design engineers in building up their full-scale manufacturing plants. The next career path that we have is process environmental engineer. They are the people who ensure industrial processes comply with environmental regulations by minimizing emissions, waste, and pollution. They are the ones who act as the watchdogs of environmental safety. And these engineers design and implement systems that most importantly minimize the environmental impact of manufacturing processes. They focus on reducing emissions, managing waste, treating effluents, and helping facilities meet the local and international environmental standards. Their work often begins by evaluating the environmental risks associated with various processes in a plant, and then they figure out ways how they can design solutions such as wastewater treatment systems, filters for air emissions, or protocols safe waste disposal. And they don't work alone, but rather they often find themselves working closely with regulatory agencies, preparing detailed environmental reports and documentation. For example, let's take an example of a process environmental engineer working in a dye production factory. The main tasks for that person could possibly be designing the wastewater treatment, monitoring emissions, and optimizing utility usage. Environmental engineers would be the central to planning and implementing upgrades for the future. So therefore, they are incredibly crucial in making sure that there are no detrimental effects of any industry that they are working in towards the environment. And the best thing is that you will once again find them working across various different industries such as oil and gas, chemicals, pharmaceuticals, mining, and literally any industry that has any form of environmental impact that must be managed responsibly. The next career path that we have on the list is validation engineer. A validation engineer is the person that verifies that equipment, systems, and processes consistently produce results that meet predefined quality and regulatory standards. They are the main key figure in industries where product quality, safety, and regulatory compliance are critical. These engineers are responsible for ensuring that every system, every piece of equipment, and the manufacturing process consistently performs as intended. Their main goal is to verify and document that operations produce results that meet all the predefined quality standards and regulatory requirements every single time without missing the mark. And validation engineers work in highly regulated environments, and therefore their role involves developing validation protocols, executing tests, analyzing data, and compiling through reports to prove that systems are working correctly. This process might include tasks such as equipment qualification, cleaning validation, process validation, or even computer system validation, depending on the application and specialty. For example, let's consider a validation engineer working in vaccine manufacturing. Their job could include validating the filling line to package each dose of the vaccine. This involves testing the machinery to ensure it accurately dispenses the correct volume, verifying that sterilization and cleaning protocols are effective, and confirming that the entire process is repeatable and safe. And if any part of the process fails, it must be halted and corrected before production can continue. And their main objective is essential for ensuring that every single vaccine dose is safe, consistent, and effective. And just like I said, and as you already may have guessed, you will find validation engineers working in highly regulated industries, such as your pharmaceutical industry, the medical device industry, food and beverage industry, or even the cosmetics industry. And these are the people that have a great deal of responsibility on their shoulders, because in all of these industries, they play a critical role in protecting consumer safety and upholding the credibility of the company's products. Another career path for chemical engineers is a cost engineer. A cost engineer is the person that estimates, monitors, and controls the cost of engineering projects to ensure that they are completed within budget. In very simple terms, they are the financial strategist behind the scenes of engineering projects. They are the ones who are estimating, tracking, and controlling the project costs while meeting the technical and safety standards. In very simple terms, their role is all about balance, making sure that the project is financially viable without sacrificing quality or functionality of the engineering project. Now, obviously, there's always a question about why this job cannot be done by a non-engineering person. Well, quite frankly, a non-engineering person could take care of the actual cost analysis, but they may lack the knowledge about the engineering project itself. So therefore, as a chemical engineer working in an engineering project, you have the best of both worlds. You do have the basic understanding of cost analysis, but at the same time, you also have the fundamental knowledge about how that cost analysis would end up affecting the project itself. And therefore, the responsibilities of cost engineers begin in the very early stages of the project, where they work with engineers and project managers to estimate costs for materials, labor, equipment, and any other resource that may be needed. And as the project moves forward, they monitor the actual spending against the budgets, identify any deviations, and may recommend adjustments to keep the project financially on track. At the same time, they are also responsible for assessing risks, accounting for market volatility, and also ensuring that the expenditures align with the project goals. And that's not all, because when the project ends at the end of the day, they are the main people who are responsible for making sure that everything is done as planned, and most importantly, that the project does not run out of money before they reach the finishing line. Think of a cost engineer working in an oil refinery expansion project. A cost engineer would be involved from the very start, helping to assess how much the expansion would cost based on designs and market rates. They would also be responsible for figuring out the constraints that they might possibly have due to money. They may also be responsible for keeping a close eye on the budget during construction, so that they make sure that they don't go over budget. And if they do end up going over budget, well, they need to be able to flag it, raise the alarm, and adjust the forecast as needed. They may also be responsible for evaluating the impact and propose cost-effective alternatives to minimize delays and reach the finishing line in time. You'll find cost engineers working in very capital-intensive industries where financial precision is key. Some of those industries include oil and gas, energy, or EPC firms and industries, or any other sector where projects involve high investments and complex resource planning. Another career path that we have on the list is project engineer. A project engineer manages the technical and logistical aspects of engineering projects, ensuring they are completed on time, within scope, and aligned with the design specifications. They are essentially the ultimate coordinator of engineering projects. They are responsible for managing the technical execution of a project while ensuring that everything stays on schedule, within budget, and aligned with the project goals. Their day-to-day work involves reviewing technical plans, managing timelines, resolving on-site issues, and making sure that all engineering decisions are implemented correctly in the field. Unlike a process design engineer who focuses on calculations and schematics, the project engineer ensures that these designs are actually built and function as intended. They also keep communications flowing between multiple stakeholders, from vendors, contractors, to safety officers and plant managers. And think of them as the link that connects the design, procurement, construction, and client teams, making sure that all the moving parts come together seamlessly. Now, for example, think of a project engineer managing the installation of a new chemical processing unit. While they are not designing the reactors or heat exchangers themselves, they are responsible for coordinating equipment delivery, ensuring the design is correctly interpreted by the construction team, resolving any site-based technical issues, and making sure safety standards are strictly followed. And if a delay crops up due to a material shortage or misalignment in the installation, the project engineer steps in to troubleshoot and get things back on track. And every sector that undertakes large-scale engineering work heavily relies on project engineers. Some of those industries involve, once again, oil and gas, the water treatment industry, quite often manufacturing industry, or anywhere there is an engineering project with deadlines, budgets, and technical complexity. A project engineer will be there and is essential to its success. And that was all for this video. We really hope that you enjoyed it and you learned something new. And in order to explore even more roles that chemical engineers can work in, do remember to check out our part 1 of this video on our channel as well. Also, do not forget to learn more about chemical engineering life at our website www.chemicallife.com, where you can learn more about our initiatives such as our mentorship program, our chemical engineering corner, our podcast, and much more. And remember to like, share, and subscribe to Chemical Engineering Life channel for more videos. And see you at our next video, and have a great day.